Welcome to video lecture. Myself Ashwini R.K., Assistant Professor, Civil Department, Rogni College of Engineering and Technology. Today we are going to see about dimension analysis and introduction. Dimension analysis is a mathematical technique making use of study of dimensions. This mathematical technique is used in research work for design and for conducting model tests. It deals with the dimensions of physical quantities involved in the phenomenon. All the physical quantities are measured by comparison which is made with respect to an arbitrary fixed value. In dimension analysis, one first predicts the physical parameter that will influence the flow, and then by grouping these parameters in dimensionless combination, a better understanding of flow phenomenon is made possible. It is particularly helpful in experimental work because it provides a guide to those things that significantly influence the phenomena. Thus, it indicates the direction in which the experimental work should go. The dimension analysis refers to the physical nature of the quantity, the dimensions, and the type of unit used to specify it. Here, the distance has dimension L, area has dimension L square, volume has dimension L cube, time has dimension T, speed has dimension L by T. Types of dimensions. There are two types of dimensions: fundamental dimensions or fundamental quantities, secondary dimensions or derived quantities. Fundamental dimensions or fundamental quantities. These are basic quantities. For example, time, T, distance, L, mass, M. Secondary dimensions or derived quantities are those quantities which possess more than one fundamental dimension. For example, velocity is denoted by distance per unit time, that is L by T. Acceleration is denoted by distance per unit time square, that is L by T square. Density is denoted by mass per unit volume, that is M by L cube. Since this velocity, density and acceleration involve more than one fundamental quantities, so these are called derived quantities. The table shows the dimensions of mostly used physical quantity in fluid mechanics. The applications of dimensional analysis. Development of an equation for fluid phenomenon, conversion of one system of unit to another, reducing the number of variables required in an experimental program, develop principles of hydraulic stimulated for model studies. Dimensional homogeneity. Dimensional homogeneity means the dimensions of each term in an equation on both sides are equal. Thus, if the dimension of each term on both sides of an equation are the same, the equation is known as dimensionally homogeneous equation. The powers of fundamental dimension, that is L, M, T on both sides of the equation will be identical for dimensionally homogeneous equation. Such equations are independent of systems of units. Let us consider the equation capital V is equal to root of 2gh. First consider the dimensions of the LHS part, that is equal to V, that is equal to, for velocity, V, that is equal to L by T or Lt power minus 1. Then considering the dimensions of RHS part, that is equal to root of 2gh, that is equal to, on calculating, we get Lt power minus 1. We can see that the dimensions of LHS part is equal to dimensions of the RHS part is equal to Lt power minus 1. Therefore, we can say that the equation V is equal to root of 2gh is dimensionally homogeneous. So, it can be used in any systems of units. Thank you.